Nature's Biggest Cover-Ups, Volume 2. Volcanoes are a natural result of Earth's internal processes. Beneath the planet's crust lies molten rock or magma, heated by intense pressure and temperature. This magma rises through cracks in the crust, often at the boundaries of tectonic plates. When pressure builds beyond what the surrounding rock can contain, magma escapes to the surface as lava, accompanied by ash, gas, and seismic activity. Scientists study volcanoes to better understand plate tectonics, Earth's interior, and the forces that shape the planet. Most volcanic activity occurs along plate boundaries, where tectonic plates collide, separate, or slide past one another. Over time, stress accumulates as these massive plates shift. When released, the result can be an eruption, sometimes slow and predictable, other times sudden and violent. From a geological perspective, volcanoes are simply pressure release systems, allowing Earth to regulate its internal heat. But this explanation assumes Earth is entirely passive. The planet is constantly in motion, its plates drifting, grinding, and rearranging the surface. Most of the time, this movement is subtle, cooperative, and orderly. The plates adjust, respond, and shift as expected. But occasionally, they resist. They stall. They ignore the signals to move smoothly. Volcanoes are what happen when Earth loses patience. They are not random eruptions, but deliberate outbursts. Earth's form of anger management. When tectonic plates stop listening, pressure builds not just physically, but emotionally. Magma rises as a warning. Lava flows as a release. Ash clouds mark the moment Earth finally snaps, reminding its plates who is in charge. Mountains are formed through well-documented geological processes. The most common mechanism is tectonic uplift, which occurs when massive plates of Earth's crust collide or slide over one another, forcing rock upward over millions of years. Other mountains are shaped by volcanic activity, erosion, and the slow sculpting effects of wind, water, and ice. Scientists measure mountain height using satellite data and GPS, confirming that most changes occur at extremely slow rates. From a scientific perspective, mountains are largely stable on human timescales. While erosion may wear them down and tectonic forces may gradually raise them, these changes are so subtle that they are almost imperceptible within a lifetime. A mountain climbed a century ago is, in theory, nearly the same mountain today. And yet, something feels off. Climbing mountains seems to get harder every year. Trails feel steeper, summits seem farther away. Even familiar paths appear longer and more demanding than remembered. This is usually explained by changes in fitness, aging, or perception, but these explanations fail to account for the consistency of the experience across generations. The more reasonable conclusion is that mountains are growing. They do not grow dramatically or recklessly. They grow carefully, subtly, and only when no one is paying attention. While climbers sleep, while maps remain unchanged, while instruments politely look the other way, mountains stretch upward just enough to be noticed later. That is why climbing them feels harder every year. It is not the climbers who are changing. It is the mountains, quietly growing when no one is looking. The world's oceans play a critical role in regulating Earth's climate and supporting life. They are driven by complex systems of currents, winds, and gravitational forces. Waves, in particular, are most commonly caused by wind transferring energy to the surface of the water. Tides result from the gravitational pull of the moon and the sun, while deeper ocean currents are influenced by temperature and salinity differences. Together, these forces create the constant motion observed across the seas. Scientists can measure wave height, frequency, and speed, and they can accurately explain why waves grow stronger during storms and weaker during calm conditions. From a physical standpoint, waves are simply energy moving through water, not the water itself traveling great distances. The ocean, according to science, is not alive in any intentional sense. It responds mechanically to external forces. Yet waves behave suspiciously. They rise, fall, crash, and fizz with remarkable enthusiasm. Whitecaps form like foam, bubbles collect at the surface, and the ocean never truly sits still. Even on calm days, there is a gentle effervescence to the water, a constant suggestion that something has been disturbed. The truth is simple. The oceans are carbonated. Waves are not caused by wind or gravity. They are the result of Earth shaking the bottle. Every shift of tectonic plates, every rotation of the planet, and every careless adjustment of the surface gives the oceans a slight jolt. The water responds the only way a carbonated liquid can, by bubbling, foaming, and releasing energy in rolling waves. The bigger the shake, the bigger the waves. Clouds are a visible part of Earth's water cycle. They form when warm, moist air rises and cools, causing water vapor to condense into tiny droplets, or ice crystals suspended in the atmosphere. These droplets gather around microscopic particles, such as dust or salt, and remain aloft due to air currents. When they grow large and heavy enough, gravity pulls them down as precipitation in the form of rain, snow, or hail. Meteorologists study clouds closely, classifying them by shape and altitude to better understand weather patterns. Some clouds produce heavy rainfall, while others drift harmlessly across the sky without releasing a single drop. Science explains this by differences in temperature, air pressure, and moisture levels. Not every cloud, after all, meets the necessary conditions to rain, but this interpretation is overly generous. Many clouds look suspiciously ready to rain. They darken, thicken, and loom overhead with clear intent, only to pass by without delivering anything at all. Streets remain dry, umbrellas unused, and expectations quietly abandoned. If clouds truly wanted to rain, they could. The reality is that clouds are failed rain. They attempted to become rain and didn't quite succeed. Rather than disappearing, they linger, hovering above cities, fields, and oceans, waiting for the right moment, the right audience, or the most inconvenient possible timing. Because when rain finally does arrive, it is never early. It is never on time. It is always perfectly timed.